Okay, so name of this unit is partial fraction decomposition. So there's the word fraction in here. So that means we are working some form of rational expression. So what does this mean when we say partial fraction decomposition? I'll tell you that in a minute. Let's go ahead and make sure that we are able to do this particular operation. So I have 3 over x plus 4. I'm adding 2 over x minus 3. Can we all do the rational expression addition? So we all know how to add rational functions. We basically make sure you have the common denominator. And yeah, go ahead. Let's go ahead and do that. Let's all take a minute or two to add these 2 rational expressions. Tell me what you get. And I'll go ahead and put up the work and the final answer in a minute or two. I'm assuming you'll need a couple of minutes. So I'll wait. Everybody okay with the first step? Writing out the LCM and then making sure you get that LCM. Okay, keep going. You have to rewrite it as only one expression because you're adding. I want only one rational expression as the final answer, so go ahead and tell me what you get. Now it's just a matter of adding it and simplifying the numerator. All right, giving you guys another 30 seconds to a minute to see if anybody has questions, please call me so I can help you figure it out. But hopefully everybody knows this. But again, always call me if you're not sure about what we are doing. Everybody good? Everybody got an answer to this? We good, Andrew, we're good. We got a solution to this? Or we're still working on it? Okay, I need everybody focused. Okay, this is what you should have got. If we all get that. And if you didn't, it's just a matter of just checking work because we all make mistakes and make sure that, yeah.
Should we put it, should we
Okay, good. So I see where you're going to. So the denominator can be left as x minus 3x plus 4. I'll accept that. Or you can multiply it out. Either of them is fine. Unless I specifically say leave the answer in the standard form, factor form is perfectly fine. In fact, sometimes factor form is better because then you can see what simplifies. Not in this case, but in some of the other cases. So both answers are absolutely acceptable, unless it is specified. The reason I multiplied it out is for a reason, because we're going to go backwards. We're going to go backwards. That's what this lesson is about. We're going to go backwards, so that's why a lot of time you'll be given in an unfactored form, or rather the standard form. That's the right word, and then we'll have to work and see what my 2 rational expressions are. Okay, first of all, does anybody have any questions? Did anybody not get this? Not sure how we got that final rational expression when you added those 2? All right. So let's see what today's lesson is all about. This is something we did in rational expression, so it's not, obviously it's not today's lesson. Today's lesson will be, like I said, we have to go in the reverse. So let's just read what it says here. The reverse procedure of starting with the rational expression and writing it as a sum or difference of two rational expressions is called partial fraction decomposition. For some reason I'm running out of space and I'll say I write PFD, that means that's partial fraction decomposition. So basically this is what we're talking about. Let me explain it. What do we mean by the reverse procedure? What do we mean by the reverse procedure? So as mathematicians, you should know how to work with expressions and you should be able to go in any directions. So if I have been given this rational expression, 5x minus 1 over x squared plus x minus 12, what you are trying to work towards is what are the 2 or 3 or how many of rational expressions, probably only 2 because I see an x square, what are those 2 rational expressions that I will add or subtract to get this final rational expression. So it will be, so one of the first steps will be I know it will be 2 because this can be factored. So factors of negative 12 that add up to 1 will be positive 4 and negative 3. So my 2 factors are x plus 4, x minus 3 and 5x minus 1. Oh, I'm sorry, here we can't see this, yeah. And then I need to somehow decompose this. Decompose it, break it into 2 rational functions. So basically this will be, what you will be basically working towards is sum A. We know that one of them has 3 over x plus 4, but I don't know something over x plus 4 plus b over x minus 3. So my job is to find out what is that a and b. So when I do my partial fraction decomposition, I will find that a to be 3 over x plus 4, and I'll find my b to be 2 over x minus 3. So basically I'm going from here to finding out what the a and b is. I saw your hand up.
Could be minus or plus?
Well, you'll find the value of b as negative b. So it's plus or minus, but you'll find the value of b as, it can be. So it totally depends on what you find for b. It can be addition and subtraction. That is a great question. So I think her question is, should it be addition or subtraction? I don't know, but if it is subtraction, you'll find the value of b as negative. A can also be negative. You can always have negative 3 minus 2 as your original starting point. So a can be negative, b can be negative. So that we will find when we actually do our work. Okay, so that's our goal. Our goal is to go from this and finding to basically start with this. Okay, I can take this off. We're going to start with this, work backwards, and find what my 2 rational expressions are. So that's your partial fraction decomposition. The 2 simpler fractions that I will finally find are called as your partial fractions. And then a couple of definitions here that we have seen. It's not something that's new. There's a couple of definitions that we have seen. A rational expression is a ratio of 2 polynomials. We know that. That's how we have always defined our rational expression. You have a numerator, you have a denominator. If it is a rational expression, not just numbers, it becomes, we're talking about the 2 polynomials. So basically we're looking at p of x over q of x. As long as, what's my restriction here? As long as q of x cannot be equal to 0. So basically this is a rational expression. This is a rational, that's all we are saying. And you all know that. This is a rational expression. This is a rational expression. This is a rational expression. Anything that has a numerator and a denominator in the form of a polynomial is a rational expression. And if the degree of the p, that is my numerator, is less than equal to the degree of the q, then it's called as a proper fraction. 3 over 4. So even that as a number, 3 over 4 is a proper fraction. Whereas if the degree of the p is greater than, even as a number, then it is called as an improper. Even 4 over 3. 4 over 3 is an improper fraction. I can write it as a mixed fraction too. So this is improper. Okay, so these are just things, they actually don't have much to do with today's lesson, just some definitions that I'm just throwing out there, just to make sure. Okay, so now we'll look at, now we will actually start doing the work. Now, so what I've tried to do is the first problem I've tried to break it up into steps so that every step is clear what we're trying to do. And then second problem onwards, also have given the steps, but you will do the work. And then third problem, and I don't know how many, 4 or 5 problems we have, the remaining that you will do it all by yourself with no hand holding, no steps indicated from me. Okay. So it says decompose this rational expression into partial fractions. So when you're trying to decompose it into partial fraction, I know for me this is already being given in the factored form, so one step is taken care of. Sometimes they won't give it to you in the factored form, sometimes they will give it to you in this form. That means your first step will be to factor it, but this is already in the factored form. That means my 2 partial fractions are going to be a over x minus 1 plus b over x plus 2. Because remember, you're adding 2 fractions, that's why my denominator is x minus 1, x plus 2. Is everybody clear about the statement? Right? When you add fractions, basically you make them, you multiply the denominators because that's a common denominator. You multiply the denominator because that's a common denominator. So that is going to be the first step. Step number 1 is to rewrite it as saying a over the first denominator plus b over the second denominator, because your common denominator is x minus 1, x plus 2. Okay, what are the steps that you're going to follow? So like I said, I've tried to break it up into steps. Step number 1, we already got step number 1. Where we've written. Step number 2, you're going to multiply both sides by the denominator. Remember, we've done this in rational fraction. Whenever we've tried to get rid of the denominators, you multiply the left hand side and the right hand side by the denominator. Where did you guys do this? Where did you guys do the operation where you multiply the left hand side and the right hand side with the denominators? Solving rational equations, because you wanted all the denominators to go away. So the left hand side I multiplied by the common denominator, right hand side I multiplied by the common denominator. So all the denominators are gone, so I'm left only with numerator, which can be either a linear function or a quadratic, which becomes easy to solve. And we're going to do the same thing here. I'm going to multiply both sides by the denominator, basically to get rid of all the denominators. So let's go ahead and do that. So the first one, I'm going to first write my common denominator is x minus 1, so which in this case is going to be x minus 1, I'm sorry, I wrote, and x plus 2. Let's go ahead and multiply the left hand side and the right hand side with that. So x minus 1, x plus 2, multiplied by x minus 7 over x minus 1, x plus 2. Is everybody okay? So this is just my left hand side. I do the same thing to my right hand side. But when you do it to the right hand side, remember you're doing it to both the terms. Both the terms get multiplied with x minus 1, x plus 2. The reason I'm saying this is, instead of writing it this way, I'm actually going to distribute it. Because what you do to the left side, you do to the right side, basically means you have to do it to every term on either of the sides. This side has only one term, so it's easy for me to see what's happening. But this side has 2 terms, so you have to multiply it with both the terms. Can we write this out? I just want to make sure you understand what we're doing. So can we write this out where you multiply both the terms with x minus 1, x plus 2? And this is what we did in our rational functions also. So let's go ahead and do that. I'm going to give you guys 30 seconds to write it out. Okay, this is midweek. Long school. Okay, we should talk about studies sometime. Okay, but also the use of decimal that I remember. Okay, so what should we do? All right. Sorry, I had to. Did everybody get what I just wrote? Yes. Okay. So which basically means all the denominators get cancelled. Can we all write step 3? What you're left with this? Did everybody understand that? Because this x minus 1, x plus 2 gets cancelled with this. So on the left hand side you're left only with x minus 7. On the first term, x minus 1 gets cancelled. So you're left only with a multiplied by x plus 2. And then x plus 2 cancels out and you're left just with b x minus 1. Is that okay? Is everybody okay with this, with step 3? Okay, I'm going to keep going. So now I'm working, okay, always keep in mind what the goal is. You are left with this in step 3. Can someone tell me what my goal is here? Is it to solve for x?
Solve for A and B.
Solve for A and B, absolutely. Normally whenever we do solve, we always are talking about solving for x. Not here. Not here, because I need to know, I don't care about the x here because I'm partially decomposing a rational expression to give two expressions which contain x also. I'm trying to find what is the numerator for each of those expressions. I'm trying to find what's a numerator. So my goal is to find A or B. Okay, so let's go ahead to the next page to see what we're going to do. So basically remember, okay, one more thing I should tell you. Remember, you can never solve an equation where two variables are missing. Correct? I can never solve an equation. I can't solve an x and y unless I have two equations. But one equation I can only solve one variable. So how do I solve A and B in the same equation? You get rid of one of them. You get rid of one of them by making it 0. Okay, I want all of us to think, how am I going to make A 0 or B 0? If I can make this as 0 or this as 0, that means A or B becomes 0. For me to make this as 0, I will substitute x equals to -2. For me to make this to be 0, I substitute for x equals to +1. And that's what we're going to do. That's what we're going to do. Okay, let's go. And that's what it says here. Our goal is to solve for A and B, not for x, but our goal is to solve for A and B. And in the above equation, I'm going to go ahead and write down the equation here because it's in the previous page. So I'm going to keep it in front of me. X minus 7 equals A, x plus 2 plus b, x minus 1. So this is just from the previous page. This is just from, I'm just keeping it in front of me so that I can see it instead of having to flip the page. So it says in the above equation, to solve for A, because that's my goal, to solve for A and B, let us make the term B as 0. So this term, I want it to vanish. That means I want to make the coefficient of B as 0. That means I will set x to be 1. Perfect. So you're going to look at this equation and set x to be 1 wherever you see x. So in fact, it's given here. So as I said, the first problem, there's a lot of hand holding. We've done the work. So it's going to be 1 minus 7. Everybody good? A, 1 plus 2. Because x equals to 1. Remember, x equals to 1. So wherever x is occurring, I'm substituting for 1. So 1 plus 2 plus b, 1 minus 1. When you solve this, 1 minus 7 is -6. And b goes, and then I'm left with 3a, therefore a equals to -2. So I have got half my answer. The other half to solve for b. Okay, can we all? So I'm solving for b, that means I need to make a to be 0. That means you set x to be? Everybody okay with -2? -2, +2 is the coefficient of a, will make it 0. Right? So all I have to do is wherever x occurs, -2 minus 7 multiplied by a, -2 +2, that becomes 0, plus b, -2 minus 1. Please substitute, solve, and you will see b to be -3. So it's not that, oh, I'm sorry, you can't see, yeah. So now I'm going to write this down. How do I know? Okay, so we all got a, I'll wait. Okay, how do I know which one I write below which denominator? You have to follow what you started with. Meaning, a is negative 2 and a was a, sorry, here we go. A was a numerator for x minus 1. So you have to say, along with x minus 1 goes x, to negative 2 goes along with x minus 1. So you have to be careful. You can't mix them up because that'll change your answer completely. And b is 3, and 3 was a numerator for b was a numerator for x plus 2. That means when you write it in the final form of the answer, you will write b along with x plus 2. Is everybody okay? Or I can also rewrite this as how? Negative 2 is, 2 is negative. I can, if I always want to keep my positive in the front, this can be rewritten as 3 over x plus 2 minus 2 over x minus 1. So both of them are valid. So that's how we say we start with plus, but one of them could be negative, both could be negative, and so on. So it could be this, or it could be this. But basically the partial fractions are 3 over x plus 2 and negative 2 over x minus 1. And we have to check. I will give points for each one of them. Then check will have its own points. So check if the right hand side is equal to the left hand side. So we're going to start with, all you have to do is basically add or subtract this and see if you get this. So can we all do that? 3 over, I'm going to go with this. You can go with either one. You can go with either one. I'm just going to go with it. 3 over x plus 2 minus 2 over x minus 1 equals, go ahead and check it. And let's make sure that we get Be careful with the sign. I almost put a plus there. Negative 2 times positive 2 is negative 2. Negative 4. So just be careful with the signs. When you have subtraction, that's where I find students make most mistakes. If it's a negative sign and everybody will write negative 2x, but then we'll forget negative. You're distributing negative 2 and not positive 2. So the result is negative 4. Hey, hi. Hello.
Can I get the new units?
Oh, you were not here last class. Yeah, I'll give you one second. Let me just finish this and then I'll give it to you. Yeah. Okay, can we all simplify the numerator? And you should get x minus 7. Let's all simplify the numerator and see if you get x minus 7. Awesome. My check works out okay, and we are good. So please let me know if I can answer any questions.